We're going to look at waves, look at the dynamics that cause them, derive the function of waves, and then do an example. So you have a wave on a string traveling in this direction. I'm going to show you that this traveling wave will have the form of anything you like of kx minus omega t, where k is the wave number of units per meter, and omega is the angular frequency in units of per second, or radians per second, radians per meter. Let's take a look at why this should be the solution. Imagine a simple function like y is equal to some amplitude e to the negative x squared. A simple Gaussian. At x is 0, the amplitude is a. As x gets bigger in either direction, positive or negative, it drops off exponentially. And so I have something that would look like this if this was x equals 0. Now how about instead we have a e to the negative kx minus omega t squared. Okay, at t equals 0, this would look exactly the same except you'd have a k squared up here. And so if k is big, this would drop off really fast and have a real short period. If k was small, this would be really long. Then we ask ourselves, as t gets bigger from 0, what will happen to our maximum point? And we see that it'll move in this direction, because if t is bigger than 0 as time progresses, this gets negative. In order for this to be 0, x must be positive. And so the maximum point will move to the right if this is minus omega t. And if this were plus omega t, then we would need x to be negative as t got bigger. And so this would be the form of a forward moving wave, and kx plus omega t would be the form of a negative moving wave. We can use this to find the speed of our wave. Why? Because the maximum point will move forward such that this argument will remain 0. And so delta of kx minus omega t must be 0. So we could take the derivative of this, right? These are constants, so we just have k delta x minus omega delta t must be 0. We separate these out and divide by delta t. So we find that dx dt, which is the velocity of the wave, is equal to omega divided by k. We'll check the units. Omega is per second, and k is per meter. And so we like that. This is meters per second.